how they make this. They put the unbalance to this inside. Small. You can make a big E, then your handful will look like as a big E. That's very ugly, right? But you want a small E so that you can put into it. And the rest is the increase omega. How high? As high as you can. 5 kilos. Then you have a very high estimate. And you can use even handphone, many handphone, to collapse this building. If you find out omega R, omega N of this building, and you put a handphone so that the design omega R is equal to omega N. This building will actually, when you excite the building using unbalanced mass, the size of the exciter is not such a big, small size, and you can excite it. I can excite it. I do that. It's exciting. I want to talk to you. Using similar concept, we can design the transducer. Maybe you want to measure the vibration using some sensors. Okay? You want to measure the vibration. How you measure the vibration? In old days, you measure vibration using your mouse and key. Okay? They use rod and grab a rod like this. Measure it. Actually feel it. Okay, so I suggest to you to feel vibration. Not only feel the vibration of the handphone, but when you ride the car, maybe you feel the vibration of the window by just touching it. You can feel it. You cannot see it, but you can feel it. When you ride a famous French TGV, we claim that French TGV is very noisy. And you can feel the vibration. French TGV has a very terrible squeal noise. That is the noise induced by the wheel, the wheel is vibrating. You can feel it. Can you feel the vibration of this wheel? Oh yes. Yes, it's vibrating. So what I'm emphasizing is to be an engineer, you have to be able to feel the physical quantity. Not only measuring the mass or length, time, but you have to feel the vibration. You can also feel the vibration when you hug your girlfriend. Maybe you don't feel vibration because your transducer is just collapsed and you cannot measure it, right? Feel the vibration. And how to feel it, how to measure it. Suppose I have something vibrating. And why don't I just put the mass and stiffness and put it in the case, and I have some resistance. And because it moves up and down, then I can have some voltage change. Okay? Because there is a resistance change, there is voltage change. Ohm's law says resistance change the current, and current change will change the voltage. That is the schematics of the transducer. This is y of t, and this is the x of t. You can use, for example, piezoelectric material. There's a piezo material that produced current change when it squeezed, when it elongated. That's why we call it piezoelectric. The simple piezoelectric material you use is when you light. When you smoke, you have a light. You have a lighter, right? Two different lighter. One is the using friction, and you can have a light. And the other one is using piezoelectric material there. And then you can have light. You have it? This is my piezo. Anyone has a piezo type? No piezo type? Zippo usually use the friction type. Okay, anyway, I will not smoke. And you? And you have fire. Yeah. And also, when you in the kitchen, when you turn on, you hear beep, and that uses a piezo material. Maybe you can take out those piezo material and maybe use as a ceramic. Because a piezo also has a certain K and damping, and the piezo produce the currents. Similarly, we can measure the vibration using VT. Essentially, transducer means that I measure VT, and I want to know what the relation between VT and XT and YT. Meaning that if I measure VT, I can measure XT. So equation of motion in this case, same as we saw before. And what we measure is, the VT actually induced by relative displacement. Relative displacement.